Well, hello, boys and girls. This is Angel Malus here, and today we're gonna be looking at another computer craft stuff. Let's see. So, what I have here, it's well, I guess you guys can tell, seven lights arranged in a number, what they call a seven-segment display. And as you may be guessing, this looks like a time, right? But people who has made this kind of timers in Minecraft, they usually make it with the Minecraft time. So right now the sun is coming up or the sun is coming down, and the days are pretty fast, so the numbers will go really fast. They use the Minecraft time, and that's pretty easy to get because on the computer I believe you can get os.time, I believe, and in Lua. There you go, and you get that number, which is like 4 p.m. or something like that. So that one, and then it goes pretty fast. So if you keep moving it like that, it's 5 p.m. now. So it went already 1 hour, which it doesn't normally do that, right, in a day. So if you just want to keep track of your Minecraft time, then we can do that. But I want to do something more deep because um, I want to be able to have track of my time, my current time. I'm in California, so that means I am in a PST time, and some of you guys may be in like UTC or PSD or some other timelines, depending on if you're central, north part of America or England or other timelines. So the computer cannot reach. There is no API to know for the computer to know which time zone you are and what time you are in, or the computer, your actual computer time where you're running Minecraft in. So what we have to do here, and I found this really cool because this one can have API requests, or what they call HTTP request, because there's an HTTP uh, API, and then this one would send a request for a website. And if you do this like with google.com or something like that, you're gonna have back all the answer for the whole website. So the whole code that becomes google.com website, it will get back to you. So if you send a request, basically it will be like an Internet Explorer. You're just gonna have back all the answers from it. Now there is a couple of services online where you can actually get a specific string back instead of getting the hashtag open and HTML and slash and all that crazy code, which is HTML, that the explorers read. You can get just back simple text. And Pastebin uses this. If you send a request to Pastebin can answer just with the text that you need. And the program pastebin.com, the Pastebin program that it exists here, that's exactly what it does. It sends a request to this website, it receives back an answer with only the text that you want, and then it grabs all that text and puts it on a file name. Same to put the file onto the Pastebin. Basically, it sends a request with all the information on the file, and then Pastebin automatically takes all the information from the file and saves it and give you the code and whatever. So the cool thing about this is that there is some websites that give you back a string of time depending on the request that you do. Some of them are configurable, some of them are not. So I found this one that is called timeapi.org. api.org, just like that. And this one, if you send a request, it will send you back an answer, a very simple answer. So let's go ahead and try doing it. But before this, I mean, this is not set up yet. I just put some redneck cable back here. You can do it with bundle cable, but redneck cable works well. Now, each of these segments has to be separated. There are 7 lights, seven separate parts that light up. But each bundle cable only have 15 or 16 colors, right? White, orange, magenta, light blue, you know those ones. But obviously there's way more than 16 lights that we need to individually light on. So that's why I'm separating the computer to have some on this side and then some on this side. So we're going to be managing the hours with one side of the computer and the minutes on the other side of the computer. Does that make sense? I hope so. Okay, on the back, as you can see, I only connected one of these lamps um, on each side. So I'm not connecting all the lamps, because as soon as you send power to this one right here, this one would automatically power that one. So you don't need to light it all up. You can do this with bundle cables or other stuff that you can use with the bundle output from the computer. So bread power to bundle cables or Mind Factory reloaded BreadNet cables. Now this one would have to have a color, right? So this one is white. Maybe this one I want to put orange. Maybe this one I want to put the second after orange. What is it called? Magenta, of course. There. And then this one I want to make it light blue. And this one after light blue, what yellow. And this one will become lime. And so on and so forth. So basically, to turn on the number 1, we need to turn this light on and this light on. So if we come over here into Lua, and then we do rs set bundle output on the right side of the computer, we will have to send a signal over here, and this is the value 1, and this is the value 2, and this is the value 4, and this is the value 8, 16, and 32. So if I want to turn this 2, I need to turn 1 and 2, which means 3. So if I send a number 3 out there, probably, yeah, this one is white as well. That's the reason why it turned on. So this one I'm gonna make it next after magenta pink, and this one I'm gonna give it the lime. There we go. And all of this is white, and we're turning on white over here, so obviously all of it turned on. So don't worry for that one. So you see we turn number 1 over here. That is cool, right? What if we want to turn number 2? Then we need to turn this one on, 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 and turn that one off. For this, we will have to turn the line, which it's 1, 2, 4, 8, 16, 32. So we need to add 32 plus 1 plus, what is this? 64 plus, I mean, it becomes crazy, right? And this is just so we can have the value of number 2. Now, for this thing, I was having, I mean, you can do it. It only takes a little bit. You can start writing all your code and all. But I was too lazy about it, and I just decided it would be too much more cool if I learn another program. So I learned to program in Objective-C, which I'm using a Macintosh computer over here, and I have an iPhone. And I thought, why not? Let's make an app for the iPhone that calculates all these numbers, and then it can give me a list of numbers that I need to put for my digits. So I went real quick to the library because I didn't know nothing about Objective-C, and it looks horrible when you see it as just a mess. There's nothing that compares to it. I program in C and Java and JavaScript, and I program for Arduino, which is very close to Java. I mean, I program in many languages: Fort, Pascal, Fortran, Basic, Visual Basic, many languages, but nothing that looks like Objective-C. It's just crazy. All those tags and sending messages to objects and whatnot. Anyways, I went to the library and I found a couple of books. I started reading them, and by the end of reading the books, I could make a little application. Now I'm gonna show you guys what I did. So here's my iPhone. Basically, right now is called mirrored. I'm mirroring my iPhone over here. I cannot click on here, as you can see, because it's actually on my phone. I have it on my hand, so you can actually see what I'm clicking. So I'm gonna click that CZ colors that I did, and as you can see, it's not really much. I didn't like fancy it out, but you can see the 16 colors right here. It has an output here. It has a clear and a reset button. So all I need to do is arrange these colors into the shape of the digits that I want to print out. I mean, if I want to do a circle or whatever, I can do that as well. So I'm going to grab it on my hand, and I'm going to move this one over here. No, I think I put it right here, right? And then this one was out here. This one down here, and then I think I went up like this. The magenta wasn't, I mean the line was on top and the green was in the middle. As you can see, they're turning red, the edges, and it's giving me an output, but I don't want to turn those on. There, I click on them and turn off. So I turn this 2 on, and it gives you the output number 3. There you go. Now I want to turn on number 2, which will be exactly like that, and there you go, 109. So if I come back over here to the computer and I do the same, but instead of sending a 3, I send a 109, what's going to happen? Number 2 is going to turn on. How's that? Isn't that cool or what? Now, that is cool. That is fine. But what happens? I mean, you can probably do the 10 digits like that, and that's fine. But what happens when you actually start doing the rest for the other one? I mean, the last number over here is what, 64, but then over here is gonna start with 128, 256, 512, 1024, 2000. I mean, it goes bananas. So we're gonna be using that application because this phone app, you can actually arrange to put the next ones out. So the next one would be gray probably, and then light gray, and then cyan. And let's do that here first before I commit more mistakes than I'm supposed to do in one episode. So pink, gray, there you go, that's gray. And then this one would be light gray, right? Light gray. And then after light gray, it comes cyan. There you go. And after cyan, it becomes purple, I believe. Gray, cyan, purple. And then after purple, it's blue. Blue. There we go. And then after blue, it will be brown. I mean, I don't even need to take be in order over here. I can put blacks and whatever. Oh, I just passed. Blue, brown. There you go. And then after brown, it's green, right? That's what I just saw. Blue, brown, green. There we go. Now all of them are off. So if you want to turn, let's say, the number 32, you have to turn on this, and then you have to go on the back and look at all the numbers and see which one is which one and try to turn it on, and it's just a mess, right? And not just that, but you have to add these huge numbers like 1024 plus 512 plus 64 plus, you know, whatever you're turning on. But let's say I want to do it on the over here. So I'll just come over here and make my arrangement exactly like the ones that I did on the game. And I believe the green was in the middle. There you go. And I want to turn on the 32. I just turn this on over here, and it gives me that number right there, 13293. So that means I come over here, and I put 13293. And guess what? Number 32 right there. Easy as that. Now, what we're going to do, it's a program that is going to start having those numbers out. So we're going to go edit, and I always edit a test. Never edit startup. That's crazy. Once you make a program that breaks the machine, then you have to break the machine. It just becomes a mess. So just edit something that is not a startup, please. Okay, edit test. So for this, we're gonna be using the output as we use it on Lua on the command prompt over there. But instead of going all crazy about it, we're gonna go into a more formal, because I don't want to do 100 different codes for each one of the possible outputs from 00 to 60 or whatever. Well, there's actually 60 possible options, but I still don't want to write 60 different codes. So what I'm gonna do, it's write 10 different numbers for the digits, the single units, and 10 different numbers for the decimals. Well, I don't think it'll be 10, but I'm just gonna do it just in case I will ever need it, right? So other way to do this would be, I'm actually gonna exit over here and I'm just gonna show you Lua. So rs.set, bundle output. There you go, bundle output, right? Other way to do this is colors. There's a colors.api. that when I do colors white, then only the white turns on. And then you can do colors white plus colors orange, and then that turns on. But obviously, if you guess to turn on the number 32, how many colors you have to add? So that is crazy. That is just a no-no. Just so don't do that. Basically, this is just the value of 1, this is the value of 2, and then it just adds it up. So we don't do that, right? Okay, let's edit the test. Now, if I want to do units, okay, so let's say uni for units, and I'm gonna make it variable. I guess by this time you guys should know what is a variable, right? U is equal a number plus whatever. Okay, but if I do this, I'm not gonna work with a single variable. This is gonna be a nested variable. So it has different, it's called like a table or something like that. I don't know how to explain it to you guys, but it's different numbers are gonna be attached into this single variable. And I'm gonna be calling them out as uni and then open and close brackets, and then it could be a register, number 1, number 2, depends on the order that I'm gonna put in. Obviously I'm gonna put them in order. So the first one that I need is a number 0. So to turn on the number 0, I'm going to go over here. I'm going to turn this off for now and turn this number 0. So you see all those are on. So 0 is 63. All right, so we start with 63. So 0 would be 63. And then I'm going to separate it with a comma. This over here is going to mean a comment. So I'm just going to comment it 0, so I know that's a 0. And then 1 was number 3, of course. We just saw that, right? That will be 1. And then what was number 2? You guys remember? Yes, exactly. 109. That will be number 2. How about number 3? Well, I will start counting numbers unless I have this app. I just do this, and that's 103 right there. So I come over here and I just click 103, comma, and I can put a number 3 there. You see, and I can just put it straight in line. I can put 63, 3, 109. I can put it in one line, but I'm just doing this so I can actually have like an order, so I can know what I'm talking about. Or like once I come later on to see the program or whatever, then I can look at it. Now, as you guys can see, I already did number 4 over here is 83. So 83. You see, this mix program is so much more easy if you actually know what you guys are doing. So this is number 5 right there, and this is 118, 118, comma. That will be number 5, and then number 6 would be 126. 6, almost on, almost on. Number 7 would be 35. I mean, if you want to exercise your brain, you can. Just trying to add all those numbers from there, but then it will go crazy when you get to this side. So then we get number 8, which is pretty much everything together. So that's not hard to guess. That's 123 with all the numbers together. That would be number 8. And number 9 finally, no, wait. It's not 123, it's 127. There you go. Because it has 7 digits, so it's 128. Okay, and then number 9 would be 115. Okay, so that's that. 1, 2, and 9. There we go. Now I have a variable over there, uni, that rolls through all those numbers, right? So let's do a for. For I equal, this is just a loop. 1, I think it starts with a 0, but we'll see what happens. 29, I think it's 0 to 10. No, let's do 1 to 10. Let's do 1 to 10, do, end, And here we're going to repeat a loop. So we're going to be turning on the light and then turning off, turning on the next one, turning off, okay? So I is going to be a counter. So I is going to have the value of 1. It's going to go through this code. Let me just give you some more space. It's going to go through whatever is here, and then is when the ends is going to return over here. If I is under less than 10, or it's not yet 10, it will return and do it again. But the I will be the value of 2. And then at the end, it will add one number to the I, and then it will come back to the beginning, and now I will be the value of 3. And it will go repeat that 10 times. So that's for I equals to 1 until I is equal to 10, do the next things. And it will repeat inside here. So what we're going to repeat is basically just the redstone output, which is rs.set bundled output on the right side, comma, and then the value, which is not I, because we will just be sending 1, 2, 3, 4, 5, 6. What we need to send is the actual list over here. So U and I, open bracket, close bracket, and then put the I inside there. So I, when it's 1, if you do uni open bracket, close bracket 3, it will grab this number over here. So it will be like either one of this. I'm not sure if it starts with 1 or 0. It will give us an error at the end. So it will send that output, and then we can tell it to sleep a little bit so we can actually see what's going on. And let's make it sleep for 1 second, of course. And then let's just test that. Test. So what's going on? 1, 2, 3, 4, 5, 6, 7, 8, and 9. That looked perfect. It seems like it did start with a 0, right? Yeah, it didn't throw a 10. There you go. 0, 1, 2, 3, 4, 5. Perfect. You see how hard was that? It was pretty quick to light up these digits. Now let's do this one over here. Now the funny thing over here is, here it is. Okay, we're gonna do it here. If I turn everything off and I just turn 1 on this side, you see it's already number 384, and this has absolutely nothing. So this by itself would be 384, and then a number 2 would be that number. Horrible number, 1300. Well, you get it. So if I want to add, let's make that simple one. Here you go, 384. If I want to add a 1 over here, I just turn those two on, and because these two were number 3, it's 384 plus 3. But we already have all these numbers from here, so all we need to add is the digits on this side. And as you can see, we can just add them together. And if we just add them together, then they will come out as they are, right? As a whole digit number, right? So we just need to add the value of each of the decimals into the value of each of the single units. So we don't need to look for those. We just need to get the decimals for now, okay? So we're gonna be doing that. Edit, test, yeah, edit test. Now we're gonna go for the decimals now. And I'm just gonna call it DAC, curly brackets, close curly brackets, and now we're gonna go for it. So number 1 was 384, and that will be 1. And number 2, we saw some huge number. It was 13952. That's number 2 according to this thing. 13952. I'm not even gonna think about it. It's just gonna happen, okay? And all I did was this application, I just give a value to each one of them, and then you can just drag them whatever you want, whatever color disposition that you want, and you can just click on it on and off, and it will just add or subtract the number that they belong to. So that's a pretty cool thing. So number 3 would be 13184. That will be right here. 13184. And number 4 would be 10624. And as you guys can see, I'm actually doing it on the iPhone. I'm actually doing it real time with my hand down there. Ooh, that didn't sound right. Okay, never mind. Number 5 is 15104. You guys can see I just did it. 15104. Number 6, I just need to turn that on. 16128. 16128, comma, and you don't need to put this green stuff. You don't even need to like do it on another paragraph. I mean, to cross the line over, but I just do it just for sake of clarity. 7 is 4480. 8 is gonna be a fun one because that's the maximum you can get. So 16256. 16256. Wait. Oh yeah. And then finally we need to turn these two off and we get 9. 14720. So 14720. There we go. And that would be 9. Alright, now how we're gonna mix those two together. That's the deal. So what we're gonna do, at least for now, I mean just for this example, at the end we need to add the decimal numbers, so whatever is in here, plus the unit numbers, right? And we're gonna repeat the unit numbers as much times as the decimals we need, right? Yes, just say yes. So inside this for loop, this is for loop, it's gonna repeat, right, 10 times. But we need to repeat this 10 times 10 times, right, starting with the 0. So we're gonna put this inside another for loop. How's that? So for j equal to 1 till 10, do the next. So when j equals to 1, it's going to repeat 10 times this while j is equal to 1. So I'm just going to put j right there. And as you guess, by the end, we will repeat from 0 to 9, and then j would increment 1, and it will give me number 1, and then it will repeat over here. So let's see. Now let's try to make this a little faster because it's going to take a lot of time to go through 100 numbers, or maybe we can just break it. Okay, let's run that. And there we go. 1, 2, 3. There you go. Good, look good, look good. I'm not gonna wait until 100. But I just saw a problem. When I run it, it started immediately with 1. So I made a problem here. I made a boo-boo. Edit test. Let's see. I never put number 0. That was my problem over here. And to fix it, it's as simple as I come over here, look at the value for 0, it's 8064, and I just put it right here where the first number should be, 8064, comma, that will be 0. So there you go, 0, 1, 2, 3, 4, 5, 9, perfect. Now, let's do that now. Run it. Now we start with a 0. 4, 5, 6, 7, 8, 9, boom. There you go. That looks beautiful right there, right? Yes, yes. Okay, nice.